Let's continue our lecture video series in integral calculus. Now, let's continue here in example number 6. Integral of dx over x plus 5 squared. Now, we can write this as integral of x plus 5 raised to negative 2 dx. They are still the same. Now, using again the pattern discussed in the previous video, we have here the u equal to x plus 5 because the exponent is negative 2. If negative 2 is n, therefore u is x plus 5. Okay? So the derivative of u here is equal to dx. Now, imitating this pattern, so integral of u raised to n and then derivative of u, so that we can proceed with this pattern of the answer. So we now have equal to the u, which is x plus 5. Then the exponent of negative 2, and then the same, the du here is dx. So as you can see, unlike in the previous video, we need to balance it by putting a constant in this portion. But this time, we are not going to put any constant because of not having any constant in this portion. Okay? So using the pattern, this is now x plus 5, which is the u here, raised to the power of negative 2 plus 1 all over negative 2 plus 1. And then don't forget plus c because the integral sign has already been removed. So that is equal to x plus 5 raised to the power of negative 1 all over negative 1 plus c. So this is now equal to negative x plus 5 raised to negative 1 plus c. Or this is equal to negative 1 all over x plus 5 plus c. Now, in checking, let's derive negative x plus 5 raised to negative 1 plus c. That is equal to negative, then bring down negative 1, the base x plus 5, the exponent minus 1, then the derivative inside, derivative of u, which is 1, plus derivative of constant 0. Now that is now equal to negative, this becomes positive. Positive 1, then we have there x plus 5 raised to negative 2, therefore that becomes 1 over x plus 5 raised to 2. Okay, so again, similar to this one. Therefore, our process is correct. So that is for number 6. Let's go for number 7. For number 7, we have integral of dx over 2x minus 7 raised to 4. Again, we can have this into 2x minus 7 raised to negative 4 dx. So using the pattern, integral of u raised to n du Then that is equal to u raised to n plus 1 over n plus 1. So we have here the base u in this pattern is 2x minus 7 and the exponent is negative 4. But the question is, what is the du? So obviously, if you look at the du is not dx. That's why we are using the let u here. So let u is equal to 2x minus 7. Du is equal to 2 dx. So it's not just dx. So if we substitute it into this pattern here, we complete that pattern so that it will be compatible with this entire formula. Substituting the values, we have here the integral of the u, which is 2x minus 7, the n, which is negative 4, the du, our du is 2 dx. Now, in the original, the given function here, we have dx only, but no 2. So to balance it, we will put 1/2 outside the integral sign so that we can cancel this out and we can still return to this original form. Okay, so we can now set aside this one and focus on this portion. So this is 1/2. The u here is 2x minus 7. So we're already following this format here. Then negative 4 plus 1. Negative 4 plus 1. Don't forget plus c because integral sign has already been removed. That is equal to 1/2 2x minus 7 raised to negative 3 all over negative 3 plus c. So the answer here is negative 1/6 2x minus 7 raised to negative 3 plus c. Or you can have the answer as have there negative 1 all over 6 times 2x minus 7 raised to 3 plus c. Now checking if our answer is correct, we need to derive the answer and see if we can return to this original form. So we have there derivative of negative 1/6 2x minus 7 raised to negative 3 plus c. So that is equal to negative 1/6. Bring down negative 3, the base 2x minus 7, this is the u, then the exponent negative 3 minus 1, then deriving the u, the one inside the parenthesis, we have 2, then plus 0 for the derivative of c. Actually, here it's actually 2 minus 0 plus 0. So that is equal to 6 over 6 2x minus 7 raised to negative 4 plus 0. That is equal to 2x minus 7 raised to negative 4, or that is equal to 1 over 2x minus 7 raised to 4. Okay, so as you can see, we were able to arrive on the original equation. Next, for number 8, integral of x and 2 minus x squared. So how do we solve this? As you can see, it's only raised to the power of 2. So we can as well expand this. So the expanded form, this one is x times, this is a 4 minus 4x plus x squared. So if we expand that, then we can distribute the x and the integral sign also. So this is integral of 4x dx minus 4. So 4x squared dx plus integral of x raised to 3 dx. Okay, then that is equal to, we can remove the constant. Actually, you can go straight right away this portion and you can remove this part. So minus 4x squared dx plus integral of x cubed dx. Now using again the pattern, we have here 4x raised to 1 plus 1 all over 1 plus 1 minus 4x raised to 2 plus 1 all over 2 plus 1 plus, this is x raised to 3 plus 1 over 3 plus 1. Then don't forget plus c. And we have there 4. This is 4x squared over 2 minus 4x raised to 3 over 3 plus x raised to 4 over 4 plus c. Then simplify, we have here 2x squared minus 4 third x raised to 3 plus x raised to 4 over 4 plus c. Okay, so that is the answer. Checking. So we will derive the answer. So d dx 2x squared minus 4 third x raised to 3 plus x raised to 4 over 4 plus c. That is equal to 2. Bring down 2. X raised to 2 minus 1 minus 4 third, bring down 3. X raised to 3 minus 1 plus 1/4, bring down 4. X raised to 4 minus 1 and plus the derivative of constant 0 equals, this becomes 4x minus 4x squared plus x raised to 3, and that is equal to x 4 minus 4x plus x squared. So this portion here is already similar with this one. That's why if we go further, this becomes x 2 minus x squared. And this is similar with the original, okay, the given here. So this is for number 8. Next, for number 9, integral of y squared dy over 1 plus y raised to 3, and this is all raised to 2. This is kind of tricky, but first let's look at the form here, we can rewrite this as y squared 1 plus y raised to 3 squared dy. Okay. If you look at it closely, it's like complicated, but using the pattern, it might not be that complicated at all. So let u, again, we will always try to make it similar to this pattern here in order for us to use the pattern for the answer. So let u is equal to, now if I let u is equal to y, of course the derivative here is dy. The du here becomes dy. And if I substitute u as y, the n of u is 2, and then the du is dy. Look at how this portion is missing. So we cannot let u is equal to y. So that is wrong. Now how about let u is equal to 1 plus y raised to 3. Now what is the exponent of this? The exponent is 2. Okay. Now du is equal to 0 plus 3y squared dy. Or that is du is equal to 3y squared dy. Now if we try to use this pattern, we will write here integral of the u. The one we used here as u is 1 plus y raised to 3, and the exponent that we will use will be the exponent of 1 plus y raised to 3, which is 2. Then, what is our du? Our du is 3y squared dy. So, is this now similar with the given here? No, it's not similar because although we have here the u raised to n, and then we have y squared dy, so y squared dy, the constant 3 is not found in the given. So we can balance it by putting 1/3 outside the integral sign, and we can disregard this portion here. So we will just focus on this portion. So that is equal to 1/3. Then using the pattern, again, this is the u, 1 plus y raised to 3, the exponent plus 1 all over 2 plus 1 plus c, because the integral sign has been removed. So that is equal to 1/3 1 plus y raised to 3 oh, this is negative 2. Yeah, so this is actually negative 2. So we can just write it here, negative 2. Sorry for that. That is our correction here. So negative 2 plus 1. So therefore, the exponent here is negative 1. And also, we will change here as negative 2. Okay, let's continue. So negative 2 plus 1 is negative 1. And don't forget plus c. So the final answer here is negative 1/3. 1 plus y raised to 3 raised to negative 1 plus c. Or we can have it as negative 1 all over 3 times 1 plus y raised to 3 plus c. So that is the number 9. Checking. So let's see if what we did is correct. Can we turn this answer back to the given? Let's see. So dy of negative 1/3 1 plus y raised to 3 negative 1 plus c. That is equal to negative 1/3. Bring down the exponent negative 1. Oops. Then the base 1 plus y raised to 3. Negative 1 minus 1. Then the derivative inside. Then this is 0 plus 3y squared dy. So 3y squared plus the derivative of constant 0. So that is now equal to 1/3 1 plus y raised to 3 negative 2 3y squared. So we can cancel out 3 here. So what's left is y squared 1 plus y raised to 3 raised to negative 2, and that is equal to y squared all over 1 plus y raised to 3 squared. So this is the given. We were able to get the given. So that is for example number 9. Now for example number 10, we have here integral of x raised to 4 plus a raised to 4 all over x raised to 3 dx. Now let a raised to 4 equals constant. So this is constant. How do we solve this? So we can actually have this in the form of integral of x raised to 4 all over x raised to 3, or can simplify this as x raised to 4 over x raised to 3 plus a raised to 4 over x raised to 3 dx. So this is equal to x plus a raised to 4 all over x raised to 3 dx. Distribute integral of x dx plus, now this here a raised to 4 is constant, so we can put it outside the integral sign. Integral of, this is x raised to negative 3 dx. Okay, next, using the pattern again. So we have here x raised to 1 plus 1 all over 1 plus 1 plus a raised to 4 x raised to negative 3 plus 1 all over negative 3 plus 1. Then don't forget plus c. This is equal to x squared all over 2 plus a raised to 4. And this becomes x raised to negative 2 all over negative 2 plus c. So we have here x squared all over 2 plus, or this becomes minus. So this becomes minus a raised to 4 all over 2 x raised to negative 2 plus c. 4. This is x squared all over 2 minus a raised to 4 all over 2x squared plus c. Checking, let's see if we can return to the given. So for the checking, the derivative of x squared over 2 minus a raised to 4, 2, x raised to negative 2 plus c, that is equal to, this is 1/2, bring down the exponent 2, x raised to the exponent minus 1, minus a raised to 4 over 2, bring down the exponent negative 2, x raised to negative 2 minus 1, plus the derivative of constant 0 is equal to, cancel 2, so what's left is x minus, or should I say plus, cancel 2, what's left is a raised to 4, then this is x raised to negative 3, this is equal to x plus a raised to 4 all over x raised to 3. So x raised to 3 for the denominator, and the numerator is x raised to 4 plus a raised to 4. So this is our given a while ago. So x raised to 4 plus a raised to 4 all over x raised to 3. So this means that these answers are correct. Now, as you have noticed, it will require you to always have the mindset that for the integration, what we do with the exponent is we add 1 for the exponents as we are integrating, and for deriving the derivation we are using minus 1 for the exponent. Then the exponents are brought down into the numerator for the derivation. For the integration, the exponents are put in the denominator. So that's the difference between the two. So that interchangeably, they always return to the given function and the integrand. Okay, so that's for this part 2.